Good afternoon, Dr. Tran.
Hey Josh, how's it going?
Good, how about you?
Good, good. What's up?
Not much. Just checking in on you.
Cool. Thanks for checking in.
Professor?
Yep, what's up?
So since the test is on Thursday for September 30th,
Yep.
Are we gonna, because I remember you mentioning we're gonna do like review. Will we be doing review on Tuesday of that week or a week ahead?
So I do my review sessions. I record them separately from the lectures. And so I'm going to record the review session on Friday. And then I'm going to post it on YouTube. And then I'll give you guys the link for the review session.
Okay, thank you.
Yeah. Mm-hmm. Yeah. So the last thing on the midterm is going to be annual cash flow analysis. And so basically the end of homework 3, that's all the content on the midterm. Yeah. So we're going to start something new. We're going to finish up a little bit of what we did last Thursday, because I know I kind of rushed that last example. And so I want to go over it again. And then we're going to start something new today called rate of return. And so the rate of return stuff will not be on the midterm. All right, it's 1 o'clock, so let's go ahead and get started today. All right, good afternoon, everyone. How's everyone doing today?
Good. How are you?
Good, good. Yeah, thanks for asking. All right, and so the plan for today is we're going to finish up our lecture notes on annual cash flow analysis. And so we had, I know I kind of rushed the example at the end of the lecture last Thursday, and so I want to make sure that we cover that. Just because it's it's the subject of the last homework problem, and it's also going to be on your exam next week too. And then after that, we're going to start a new set of lecture notes called rate of return analysis. And so rate of return will not be on the midterm, but it will be on the next one. And so something good to know, but you don't have to focus on studying it for now. Okay. So usually my policy for exams is that I want to give you guys a chance to practice it in the homework first. Before I give it to you in an exam, because the homework is a lot less stressful of a situation. On an exam, you have, first of all, limited time to do the exam and unlimited time to study it too. And so I think if you're trying to study something that you haven't had a chance to practice in the homeworks and you haven't had a chance to get feedback from me on, it's not really, to me, it's always seemed like it's not really a fair thing. And so, homework 3 is going to be the last homework that's going to be on the exam. And if you look at homework 3, the last thing that we cover there is annual cash flow. Okay, and so that's going to be the last thing you have to worry about. Okay. And so for the exam, I was talking about this a little bit before class, but I will post a study guide, and so I plan on doing that probably sometime this afternoon. And so the study guide is going to be there to help you, is to help kind of guide your study, just like how the name implies. And so if you're not sure where to start studying, I would start with a study guide and just kind of go through all the learning objectives there. And just make sure you can do all of them, okay? And so the study guide basically is going to consist of all of these learning objectives here, right? So, these things that we start every lecture with, right? And remember, I write these learning objectives in a way that basically describes what I want you to get out of each lecture, out of each lesson, okay? And so if you can answer all of the questions and you can do all the tasks that the study guide asks you to do, you're going to be in great shape for the exam. Okay? That's what I always tell people. Okay. All right, question. So would I say that reviewing notes and study guides is sufficient? It's a start. And so, a big part of the exam is you're going to have to be doing a lot of the cash flow problems that, we've been doing as examples and in the homeworks too. And so make sure you look at the homeworks too, just to make sure that you get practice doing those kinds of problems. Yeah. I would say, one of the best ways to study that I think, is, not a lot of people do is actually just redo your homework problems. And so, I spend quite a bit of time writing those homework problems and designing them in a way to help prepare you, for the skills that I want you to learn, right? And when I say redo your homework problems, I mean, don't kind of like look at the homework problem and then look at the solution and be like, oh yeah, of course I know how to do it, right? Because that's not helpful, because that's when you do that, you kind of get caught in a mindset like, oh, of course I do that, right? The best way to use homework problems to study, and this goes for all your classes too, not just for my class, is to actually look at the homework problem again, maybe one that you haven't looked at in a while, and try to do it from scratch. And so only use the class notes, basically try to redo it as if you were doing it the first time, and then only use the solutions after you're done with the homeworks. Okay. That way, you kind of train your mind to go through that process of actually doing this problem from scratch, which is exactly what you're going to be doing on the exam. Okay. And so, and I tell you this just from experience, because I ran into that, I fell into that trap a lot when I was in college, where, I would study my homeworks, but the way I would study them was I would just look at the solutions again. And then, it ended up not sticking as well as if I would actually try to redo the problems from scratch. Okay, so I would say that's kind of the best way to do the, to study the homeworks. Okay. All right, and so, yep. And so another thing I'm going to be doing this Friday is I'm going to be recording a review video. I guess it's a review video, not a review session, because it's not going to be interactive, but it's going to be about an hour-long video that I'll record where I'm going to review, the topics that you guys feel most uncomfortable with for the midterm. Okay. And so probably sometime tomorrow, I'm going to be posting a poll on Canvas where you can vote on the topics that you feel most uncomfortable with. Okay. And then based on the top results, usually I cover the top two and maybe a little bit of the third one. I'm going to cover those in the midterm video on our midterm review video on Friday. Okay. So keep an eye out for that poll. Make sure you vote on it. Okay. Usually for those polls, sometimes I only get like 3 or 4 people answering it, and so those polls are from 3 or 4 people. At least I know those 3 or 4 people will be happy. But I want to try to make everyone as happy as possible with the review video, and so make sure you look out for that and vote on it, because the more people that votes, the more people that I know it's going to be useful for. Okay. Okay, and so are there any questions I can answer before we get started for today? Okay, all right, so let's go ahead and get rolling. And so let's go ahead and just go over the example that we were doing last time on amortization tables, okay? Or amortization schedules. And so remember, an amortization schedule is basically a table or a spreadsheet that you can use to organize your payments on a loan. Okay, and so it basically breaks down your loan into all the different payment periods that you have and tells you how much you're paying towards your the principal, how much you're paying each month, how much interest you're paying, and so on and so forth. Okay, and so it's basically a way to organize payments on the loan. Okay. All right, and so let's go ahead and just jump right back into the example that we did, because I don't want to spend too much time on this. Okay. And so let's say in this example, you just purchased a new set of a new piece of furniture, a really nice piece of furniture for $2,400. Okay. The unfortunate thing is you don't have $2,400 on you, and so you need to finance it. Okay, and so the deal that you struck with the furniture manufacturer is that he's going to let you pay off the loan in 4 payments at a very low interest rate. Okay. And I think last time I tried to do this example with a different interest rate than what's listed on the notes. But I'm going to go with just whatever interest rate is on there right now, just so we can kind of speed through it a little bit. Okay. And so the interest rate that the manufacturer is offering you is a 0.25% interest rate. Right. And so from here, we're going to compute, how much we're going to pay each month, and we're going to organize all those payments into an amortization schedule. Okay. All right. And so first, let's compute our uniform monthly payment. Right. And so remember, the way that we're going to do this is we're going to take the loan amount. Okay. And so the loan amount in this case is a $2,400. And since this is the money that you're paying today to pay for the furniture, this is going to be a present sum. Okay. And so to compute the amount of that we're paying each month, we're going to take this present sum and convert it into a uniform series. Okay. And so our monthly payments, which will top A, okay, this is going to be $2,400, which is our P amount. And we're going to convert it to an A. And so we're going to need an A over P factor for 0.25%. And 4 years. Okay. And so this conversion factor, it actually is in the compound interest tables. And so it's actually the very first one. And so for 0.25%, this conversion factor here is 0.2516. Okay. And so we perform the multiplication and we get 603.84. Okay. Or $603.84. Okay. All right, and so that's our uniform payment amount. And so now we're going to start to organize it into a table. Okay. And I'll walk through, I'll walk through kind of the first couple rows just so you guys know how to do the calculations. And then I'll just kind of quickly fill out the rest of it. Okay. All right. So any questions on this? Okay. All right. So let's go ahead and start building that table, right? And so our amortization schedule, remember, we have 5 different columns here. And so we have 1 column for the period. And so that's basically all the different payment periods that we have. Okay. Okay. Next, we have a column for the beginning balance, which is the amount of money that's left on the loan after that first period. Okay. Or after that, or at the beginning of this period. Okay. Next, we have interest. And so interest is the amount of interest payments you're going to make on that loan, on that period. Okay. Next, we have a column for principal paid. Okay. And so after you've paid the interest amount, the rest of the money that you're paying is going to go towards your balance or your principal. Okay. And then finally, we have the ending balance. Okay. All right. And so for this problem, we have 4 different periods. Okay. Because we're making 4 payments, right? And then our beginning balance at the beginning of the first period is going to be 2,400. And so that's the full amount of the loan. Okay. All right. And so for the interest, okay. And so for the interest payment, remember the way that we compute that is we take whatever the beginning balance for that row is, and we multiply it by the interest rate. Okay. And so this is going to be beginning balance multiplied by I. Okay. Remember, I is a decimal. Okay. And so we're going to take our beginning balance of 2,400 here, and we're going to multiply it by 0.25%. And so that's going to be multiplied by 0.0025. And so if we do that, we get an interest payment of $6. Okay. Right. And so in this first period, we pay $6 of interest rate on that, on that sale. Okay. All right. And so to get the principal paid, okay, the principal paid, remember the way that we compute this is we take our uniform payment amount, okay, which is 603.84, and we subtract the interest from that period. Okay. Okay. So this is going to be A minus interest. Right. And so our uniform payment amount this time is, remember, $603.84. Okay. And so if we subtract 6 from that, then what we get is $597.84. Okay. Right. And so just to give you kind of another visual indication of this amount, or this concept, right? Remember, each month we're going to be paying $603.84, right? And so this is going to break up into 2 different bins, I would say. Okay. And so one bin, part of this money is going to go towards paying the interest. Okay. Okay. The interest being $6, right? And so when we submit that check for $603.84, the furniture office is going to take $6 out of that and say that's going to be for interest. And then the rest of the money is going to be paid towards your principal. Okay. And so, you can kind of visualize it as kind of what the money that you're submitting is going to be split up between these two contributions. Okay. All right. And then finally, we have the ending balance. And so the ending balance, the way that we compute that is we take the beginning balance for that period and we subtract the principal paid. And so this is going to be our beginning balance minus principal paid. Okay. And so if we do that for this one, for this first row, it's gonna be 2,400 minus 597.84. Okay. And so we compute that. This is gonna be $1,802.16. Okay. All right. And so after this first period of payment, and we submit our $603, we still owe $1,800.02 or $1,802.16 on the loan. Okay. And so this ending balance here becomes the beginning balance for the next period. Okay. And so then we have 1802.16. Okay. Right. And then we just repeat the same process over again. Okay. And so generally what you should notice in these tables is that because the beginning balance is going down with time, right? Or it should be going down with time, then your interest payments are going to go down with time as well, right? Because remember, the interest is just a percentage off of your beginning balance, right? And so if your beginning balance is going down, then your interest should also be going down. Okay. And so if we compute the interest payments for the second year or the second month, we're going to take 0.25% of 1,802.16. Okay. And you'll see that we get $4.50. Okay. We take that $4.50, we subtract it from our $603 that we're paying each month. And then we get a principal paid of $599.34. Okay. And so this is the amount of the principal paid is how much we're going to chip away at our loan amount. Okay. Okay. And so after that, then our ending balance is going to be 1202.82. Okay. And so that comes down here. Right. And then we just continue onwards just like this. Okay. And so I'm just going to fill in the rest of the table, pretty quickly here. Right. Right. And if all goes according to plan, then by the end of the last period, you should have $0 left on your balance. Okay. And so sometimes it's not going to be exactly zero. And so actually, if you do the math for this one, it doesn't match zero exactly. And so because of a lot of rounding errors that occur throughout this process, especially if you have a table with lots of rows, then a lot of those rounding errors are going to accumulate. And so by the time you reach the end, you might still have, you might have overpaid by a little bit, or you might have underpaid by a little bit. And that's okay. And so I think when I was doing the homework problem for this, I think by the end of the loan with the calculations I was doing, I ended up with like an extra $12, $15 left. And so that's okay. And so, because we're doing all the calculations by hand, there's going to be, round off errors like that. Okay. All right. And so let's look at the column for the interest payments, right? And so the interest payments you can see are going down with time as, just as we discussed, and the amount of principal paid is going up with time, right? Because your interest payments are going down, then more of your payments are actually going towards paying off your principal. Okay. And so that's generally the trend that you should see in this, in this table, is that interest payments going down with time. Okay. And principal paid is going to go up with time. Okay. All right. Any questions on this? Okay. And so, if you're really interested in doing this, this is often what's used to to organize your payments on a mortgage, actually. Oh, question. So principal pay is just more because you want to pay less interest. It's not that you want to pay less interest, is that the interest payments are just naturally going down with time. Because remember, the interest payments for each period is based on a percentage of your beginning balance for that period. And so because you're paying off the loan more and more throughout, right? Your beginning balance is going down. Then the percentage of that, the interest, the actual interest payments on that balance that's left is naturally going down with time. Yeah. Can the end balance go below 0? Yes. Yeah. And so, just like I was saying before, because you're doing these calculations by hand, there's going to be some round off errors. And so if you go below 0, that's okay. And so in real life, they're going to compute these a lot more exactly. And so that's not going to happen. Yeah. And so the principal pay is just going up to kind of catch up with the payments to finish it off. Yeah. And so that's one way you can think of it. Yeah. Because you remember when you're paying off a loan, you're paying a set amount each month, right? And so we've already determined that, we're paying $603.84 each month, right? And whenever you submit the payment, whatever loan office or whatever person that's organizing the loan, they're going to take a cut for the interest first. And so whatever's left from that after they take the interest out, that actually goes towards paying off your loan, right? Because eventually, you're starting off with like a tab, right? So you can think of it as you have a tab of 2,400 that you need to pay off. And so the only thing, the only payments that actually go towards paying off that balance is your principal paid, right? And so, basically the more interest that gets taken out, the less you're actually contributing towards paying off your your principal. Yeah. All right, question. So determine how much you pay for the first period, you add interest and the principal paid. And so the amount that you're paying each period is the same, right? And so remember, the amount that you're paying is determined by this uniform series right here, right? And so that's the amount that's being paid. And so if you add up the interest and the principal paid, you should get the same amount every single month or every single period, right? It's just that how much of that gets taken out for interest versus how much of that gets paid towards principal, that changes each period just because the amount of interest payments that you make is different. Yeah. Yeah. It's actually really interesting. And so actually, if you build an amortization schedule for a home loan, right? And so for a mortgage, it's actually really depressing. And so you actually, because those are such a long-term loans, and so most mortgages are going to be paid off in 30 years. That's kind of the standard for a lot of loans, and you pay that monthly. And so you think about it, you're paying 30 years times 12 months a year, and so that's 300. A lot of payments, right? Let me see, 60 or 30 years times 12, right? 30 years times 12, and so that's 360. Yeah, 360 payments, right? And so if you actually look at the amortization schedule for for your mortgage, what you'll notice for your first few payments, maybe like 95, 97, 98% of your payments is actually going towards paying the interest. And so you actually don't start chipping away at your loan amount until you're 6, 7, 8 years into your mortgage. And so it's actually a little bit depressing when the amount of periods is really high because you just pay just so much interest in it. Yeah. All right, question. So does the principal paid ever go down? No, it should not. And so it should always go up because the amount of interest that you're paying should go down with time. And as the amount of interest that you're paying goes down, then your principal is going to go up. Yeah, principal paid. Yeah. If your interest payments are going up with time, then you're getting scammed. And so that's not a loan that you want to be. That's not a loan that you want to be a part of. Yeah. All right. All right. Any other questions on this example? Okay. All right. And so that's a amortization schedule. And so I think in terms of life skills, I think this is one that's really useful. Because loans is something that I think everyone takes out at some point in their life, and so in order to organize the payments or just to kind of see what's going on, I think this is always a really useful skill. Okay, and so there's one other thing that I want to go over in terms of paying off loans, and that's how do you compute the remaining balance. Because let's say that you've been working on this loan and you've been paying it off for a few years, and you want to know how much is left. Yeah. All right, question. So when it comes to taking out loans, is there an ideal time for it, or is it dependent on how badly you need the money? Ideally, you want to take out a loan at as low an interest rate as possible, because the lower the interest rate, the less extra that you're going to pay, right? And so that's kind of the most ideal time. And then interest rates, change, according to the market, according to how the economy is doing, and things like that, right? And so just to give you an example, right now interest rates are super, super low. And so if you're buying a home right now, then you're going to get a really good deal on a loan, just because interest rates are really low. But with that said, there's other factors in play too, because if a lot of times you're taking out a loan to actually make a big purchase, and so the amount, if the price of the thing that you're buying is also a huge factor of what you're taking out a loan. And so even though interest rates are really low for mortgages right now, it's actually a really terrible time to buy a house, just because the house prices are kind of insane right now. And so interest rates are really low, just to kind of try to entice people to get into a home loan, but just prices are just not there right now where it's a good decision to buy a home. Yeah, and so it's always kind of a gamble, because it's hard to predict where interest rates are going to go, and it's hard to predict where prices are going to go too for whatever you're buying, whether it be houses, cars, or or anything really. Yeah. Oh yeah, and tuition loans are also kind of a difficult thing as well. Yep. Okay, and so another thing that you can do, with the tools that we have already, is you can compute the remaining balance on a loan as well, right? And so let's say that you've made a few payments on a loan so far, so you've made X amount, maybe 7-8 payments on a loan, and you want to see how much you still owe. Okay, and so basically you want to compute whatever this is. Okay, and so you want to compute what your balance on the loan is at the time, right? Because let's say that you didn't build the amortization schedule, and you just want to find out how much is left. Okay, and so the way that you find how much is left on a loan is you basically just take the present worth, or the present value, of all the remaining payments. Okay. Okay. Because you know how much money that you're paying each month for the loan, or each year, or whatever, how often you pay the loan. Okay, so that's your A amount, and so all you have to do is compute it to a P. Okay. And so the formula here is, our remaining balance is going to be our A, where A, remember, is the uniform amount that we're paying each month. Okay. And then we're going to convert this to a P. Okay. And so we need a P over A factor. Okay. We need an interest rate I. Okay. And then the N that we're going to use is the amount of remaining payments. Okay. And so be careful using this formula, because you don't want to use the N, the total number of N for your loan, right? And so you don't want to use the total amount of payments that you're going to get, that you're paying overall. It's just however many payments that you have left. Okay. Right. And so in the last example, let's say that you've made one payment on this loan, and then you want to find out how much that you have remaining. Okay. And so you would plug in for this formula. Okay. And so in the last example, we know that we're making 4 total payments. And so if we've made 1 payment, that means we have 3 remaining. Okay. And so if you plug this in, you plug it in from the tables. You plug in your A, where your A, remember, is your 603.84. Okay. And what you should get is this 1802.16. Okay. Right. And so that's kind of a quick and easy way that you can find out, how much you have remaining on your loan, just purely based on how much you're paying each month, and how many years are remaining, or how many payments are remaining left on this loan. Okay. All right, any final questions on this before we start jumping into rate of return analysis? Okay. All right, and so let's that's it for annual cash flow, and so that kind of closes the chapter on midterm 1 topics. Okay, and so now we're going to be covering rate of return, and this is going to be a topic for midterm 2. Okay, and so definitely don't tune out yet. So don't close the Zoom call. But kind of maybe stash this knowledge for the future. Okay. All right, so let's start talking about rate of return. All right. And so rate of return is another, like we call it economic analysis technique. Okay. Okay. And so it's in the exact same vein as present worth analysis and annual cash flow, right? And so they're all kind of grouped up together. But this is kind of a different, spin or a different type of analysis than those two. Okay, because when we talk about present worth analysis and annual cash flow analysis, those two are kind of they're very similar to each other, right? And so our goals were the same, and kind of the way that we approached the problem was very similar. All right. The only difference between the two is that in one form we converted to a P, the other form we're converting to an A, right? So they're very similar. Rate of return is kind of the black sheep of the family, and so it's a little bit different than the two. Okay? Right? And so the difference here is that instead of computing a cash flow, right, which is essentially what we were doing in present worth and annual cash flow analysis. Okay? Okay. And the way that we computed this cash flow was from a given interest rate, right? So up to this point, I've always given you the interest rate for the problem. Okay. And so instead of computing a cash flow from a given interest rate, what we're going to do instead is we're going to be computing an interest rate from given cash flows. Okay. And so because we're going to be computing I now, or the interest rate, it's just going to be fundamentally a different approach to the problem. Okay. But that's not to say, we're not going to use the same tools as before. And so we're still going to use the compound interest tables or the formulas. And so actually, I've seen a lot of you guys use the formulas on the homeworks, which is, which is great. The formulas I think are a little bit more flexible. And so we can still use both of those, just that what we're looking for in the problem is just going to be fundamentally different. Okay. All right, and so let me do a simple example just to kind of illustrate this. So I think that's a little bit easier than kind of trying to explain it with words. Okay. All right. And so let's say that you've loaned out $5,000 to a good friend of yours to start a business. Okay. And then your friend is going to repay you in five separate payments. Okay. And so in 5 monthly payments of $1,252. Okay. Okay. Right. And so for this problem, we're going to compute the rate of return. Okay. All right, and so first let's start out by drawing the cash flow diagram. So it's a relatively simple case, but drawing the cash flow diagram will help. And so first we have the $5,000 that we're loaning out present day. Okay. Okay. And so that's going to be a minus $5,000 at year 0. Okay. And then this is going to be repaid in five payments, right? And so we have 1, 2, 3, 4, 5. Okay. And all of these guys are 1,252. Right, and so given these cash flows here, we're going to compute what the rate of return or what the interest rate for this problem is going to be. Okay. All right. And so any questions on this? Okay. All right. And so let's go ahead and start solving this problem. Okay. And so what we're going to do here is that, because we're given all these cash flows, we're going to set up an equation where, we're going to balance this cash flow diagram. Okay. Okay. I remember, when I say we want to balance a cash flow diagram, thinking back to homework 2, what we're doing is we're going to convert all the cash flows here to the same form, and then compute the net present worth. In this case, I'm going to do present worth, and then set it equal to 0. Okay. Okay. All right. Net present worth, right? And so let's go ahead and set it equal to 0 first. Okay. First, we have a minus 5,000. Okay. So I'm going to use red just so it's consistent with the last page. Okay. Right. And so we have a minus 5,000. And since that already is taking place in the present day, we don't need to compute it. Okay. And then to this, we're going to add our uniform series. Okay. And so our uniform series is 1, 2, 5, 2. Okay. And if we want to convert this to a present sum, we have to do a P over A factor. Okay. We don't know the interest rate, and so we're going to leave this blank as I. Okay. Okay. But we do know the number of periods, which is 5. Okay. Right. And so our unknown here is I. Okay. And so by proxy, because the I is unknown, then this whole quantity here, this conversion factor is unknown. Okay. And so let's solve this problem for that conversion factor. Okay. All right, and so let me go ahead and move 5,000 to the other side of the equation, and then we'll divide by 1,252. Okay, so we have 5,000 divided by 1,252. Okay, this is equal to P over A I 5. Okay. All right. And so we can go ahead and perform this division here. And what we can say is that this conversion factor, in order for this cash flow diagram to be satisfied, this P over A conversion factor has to be 3.994. Okay. All right. And so from here, we can proceed in kind of one or two different ways. Okay? And so what we can do first is that we can plug in the equation for P over A, right? And so if we use one of the P over A equations here and we plug it in and we can solve for I, and so that's one way we can do it. Okay. But another way we can do this is we can just look it up in the table. Okay. And so if we search the compound interest tables, if we search the compound interest tables for this factor, and so we basically look at the column for P over A, and we look at the row for n is equal to 5, okay? And we kind of flip through the compound interest tables, you know, which I know is not the it's not the funnest thing to do, because you have to kind of scroll through each of them, okay? And we're going to look for the case where the P over A factor for n is equal to 5 is 3.994, or as close to it as we can get, okay? And so for this problem, because I kind of set the numbers exactly, we can actually find this exact conversion factor in the tables, okay? And in fact, it's going to be in the tables where the interest rate is 6, okay? And so this is true, or this conversion factor is true when I is equal to 8%. Okay. Yep, 8%. Yeah, and then later on we'll do examples where it's not so nice, and that it doesn't hit it right on the nose. And so in those situations, we're going to have to interpolate, right? But we'll cross that bridge when we get there. And so let's do some more basic problems first, and then we'll get to some interpolation. Yeah. All right. Any questions on this?
Professor?
Yep.
Can you walk through how you found it to be 8%? Because compound tables usually you need the interest first. At this time, what numbers are we using to locate it?
Yeah, no, that's a good question. And so basically what you have to do is you have to go to the compound interest tables and then kind of search through each one and then find the one where that P over A factor is 8%. And so let me go ahead and share my my screen here. Okay, and so here we have our compound interest tables, right? And so we know that what we have right now is n is equal to 5, and we're looking for a P over A factor, right? Okay, and so those are the two quantities that we're looking at. Yeah. Oh yes, and so if you're lucky. If you're lucky and the exact factor is in the tables, you can just Control F and search for 3.994. And so let's go ahead and do that. If my Adobe will cooperate. And so unfortunately with that one, you might get some false positives, but here, and that's also a false positive. Yeah, and so it's not as reliable. And so if you have faith in that and you can pick the one that makes the most sense, then you can do that. But here's kind of what I had in mind for searching, right? And so since we know that n is equal to 5, we know we're going to be looking in this row right here, okay? And we know we're going to be looking at P over A, right? And so that's going to be this column right here, okay? And so what you need to do is you need to look at the P over A factor for n is equal to 5, okay? And you're going to look for the one where it equals to 3.994, okay? All right, and so if we do that for I is equal to 0.14%, quarter percent, we see that the I, or the conversion factor here, is 4.963, which is not what we want, okay? And so we just move on to the next one. We look at 0.5%, okay? And we see that it's 4.926, and so that's not right, okay? And so it's going to be a lot of scrolling. I know that, okay? And so you can just look at this one, that's not it. Look at this one, that's not it, okay? And you just go all the way until the table that you need. And so for this case, it's 8%. Okay, so you go to the table for 8%. And you can see here that it's 3.993 in this table, actually. And so
okay.
it's not quite there, but it's close to it. And so, yeah.
Just one follow-up question. Will we ever find a PA that would be relatively like a little bit like more, and this one's a little less? How would we decide to choose which one? Like, let's say this one's 3.993, which is near our 3.994.
Yep.
What if we found one that's 3.995 on accident?
And so if you're like within, if you're at the third decimal, I would say that that's pretty much right on the nose already. Then you're only doing, the differences between those cases are very, very small. But later on, you'll see that, we're going to come across cases where, we're not going to be anywhere near a close number. And so we're going to be in between two tables, right? And so as an example here, let's say that we're doing this one and we end up with a conversion factor of like 4.05, okay? And so 4.05 will be in between this one, which is 4.1, and in between this one, which is 3.993. And so in those cases, you have to interpolate, okay?
Right, thank you.
Yeah, and so those ones are going to be a little bit more annoying, but I will say that for the homeworks, because I kind of give you the answer to the homeworks, I kind of tell you already where to start looking. And so, this is actually one case where the homework doesn't give you the best practice, because I kind of already tell you where to start looking, and so you don't have to look through all 32 pages of the compound interest tables. But traditionally, if you don't know where to start looking, you would kind of start somewhere and kind of just search as much as you can. Yeah. But we'll cross that bridge when we get there. Yeah. All right, so let me go ahead and bring my iPad back. Okay. All right, and so for this case, it worked out really well. My voice just cracked, but for a lot of cases that we'll see later, it's not going to work out as nice. Okay. Okay. But the compound interest tables are not your only option, and so you can. There's another way that you can do this. That's actually a lot more reliable than the compound interest tables. And that's to actually use the formulas. Okay, and so for you formula fans out there, this one's for you guys. But unfortunately, you kind of have to combine the formulas with MATLAB, and so MATLAB is kind of the way to do this. And so I call this kind of the table way, or the table method for solving rate of return problems. But there's also a formula and plotting way, which I'll show you on the next page. Okay. And so let's talk about the plotting. And this plotting method is I would say is really consistent. And so I would say it's maybe a little bit annoying to set up, just because you have to type in formulas into MATLAB, but you don't have to do any interpolation. So there's a little bit extra on the setup, but I would say this gives you consistent results, and it's always going to be good because it's as exact as you can be. Okay. All right, and so let's go ahead and set up the formula that we had on the last page. Okay, and so we said that our present worth, is equal to 0, okay, which is equal to minus 5,000 plus 1252 times P over A, I, and 5. All right, and so the way we did it on the previous page is we solved for this conversion factor and looked it up in the tables. But another way we can do this is we can take this factor right here and use the P over A formula. And so we can say plug in P over A formula. Okay. All right, and so the formula for P over A, if you think back to one of our very first lectures, okay, is going to be 1 plus I raised to the n minus 1, all divided by I times 1 plus I to the n. Okay, and so let's go ahead and plug this formula in, and plugging in n is equal to 5. Okay, and what we get is present worth is equal to minus 5,000 plus 1252 times 1 plus I raised to the 5th power minus 1 divided by I times 1 plus I raised to the 5th power. Okay. All right. And so now, the idea is to solve for I from this equation, right? Set it equals 0 and solve for I. Algebraically, if you want to do it by hand, it's going to be really difficult, just because you have this exponent of 5 here, right? And so unless you really love algebra, or you have a lot of time on yourself, solving this by hand for I is going to be a nightmare, right? And so the way that I usually solve these kinds of problems is I take a complex function like this, and then I plot it in MATLAB, okay? Right, and so let's write this formula in MATLAB. Right? You can also do this in Excel if you're good at writing formulas in Excel. Right? Personally, I think it's a little bit inconvenient to make formulas in Excel, but I know a lot of people are really good at it, and then more power to you. But I personally prefer MATLAB for these kinds of things. Okay? All right, and so the way that I plot this is we're going to create a vector for interest rates. Okay, and so this is going to be the x-axis on our plot. Okay, right. And so let's go ahead and make an interest rate vector here. Okay. And so this is going to be from 0.006. Okay. And so the increment on this is going to be 0.001. Okay. And it's going to be up to 0.1. Okay. Right. And so what this line of code right here is, it creates a vector that has interest rate values from 6% to 10%. Okay. Okay. Right. And so you can see here that the bottom bound for our vector here is 0.06, and so that represents an interest rate of 6%. And then the upper bound for our vector here is 0.1. Okay. And so what this vector is going to be is going to have all the values from 0.06 to 0.1. Okay. With in increments of 0.001. Okay. Right. And so basically the way you can think of this is, we're going to pull, or we're going to basically test all the interest rates in this range, and to see if it satisfies this equation right here. Okay. Right. So everyone here is taking 205, right? Or you're currently taking it. And so, you've seen code like this before, where, you create a vector. Good. Okay. Yeah. And so, this is the way I kind of do, but I know there's a lot of different ways you can create vectors, but this is kind of a way that I like to do. Okay. And, I will say that, this MATLAB method here is not required. And so, we're going to go over lots of different ways that you can use the compound interest tables for it. But this is kind of just for your interest. If you feel, particularly savvy with MATLAB, and you want to try it with MATLAB, this is the way that I would set it up. Yeah. I haven't taken MATLAB in 2 years. Yeah, it's a useful skill. I like it a lot. I will say that I'm very biased just because I like programming, but I think it's really useful. Yeah. Okay, and so that's the first line of code, and so we only have to write 3 more lines of code, actually. Okay, and so before we do that, are there any questions on this?
Professor, where'd you get those numbers for the increments and the maximum and minimum?
Yeah, and so in this case, I kind of already know that the interest rate is 8%, and so I'm going to check basically all the interest rates around it, and so basically, I'm going to check 2% down, and so that's going to be 6% on the left side, and then 2% greater than that, which is going to be 10%. And
okay.
Yeah, and so that's how we got 0.06 and 0.1. And then just to make sure that I'm checking a lot of interest rates in between that, then I set the increment to 0.001. Yeah. Okay. And so the next step is to write the MATLAB code for the present worth. Okay. And so basically, we're going to take this formula right here that I've boxed and then put it into MATLAB form. Okay. All right. And so I think this is the most annoying part, is to take a complex equation and then put it in MATLAB. Okay. And so we're going to make a new variable called PW. And so that's going to be minus 5,000 plus 1252 times. Okay. All right. And so we have 3 parentheses here. So we have 1 plus I dot caret 5, okay, minus 1, right? And then we're going to do dot divide by dot divide I dot times parentheses, just 1 parentheses, 1 plus I dot caret 5, okay, 2 parentheses, and then semicolon, okay. And so all this line of code does is that it just puts this formula here that I have boxed into MATLAB form, okay. All right, and so this PW variable right here, this is going to be the y-axis in our graph, okay. Whereas this I variable right here, this is going to be the x-axis. Okay. And so all we have to do now is just plot them, right? And so we can just do plot, okay, I, comma, PW. Right. And so that's going to plot basically for all the interest rate values that we have, it's going to create, our plot for us, right? And so if you look at the graph, it looks something like this, okay. All right. And so the key here is to look at and so the key here is we want to look at the location where the graph crosses the x-axis, okay. Okay. And if your formula is well designed, then it's only going to cross the x-axis once, right? And so for this particular case, the graph looks something like this. Okay. Okay. Where it's going to cross the x-axis here at x is equal to 0.08, which, as we know, is 8%. Okay. Right. And so because the graph here crosses at 8%, or it might be something like 7.99 something, or 8.001 or something like that, okay, then that's going to be your rate of return. Okay. All right. And so this is another way that you can solve these rate of return problems. I'm not going to give another example of this just because they're all more or less the same. But you can actually do all of the rate of return problems like this, right? And so from here on out, I'm going to go back to using the compound interest tables. But in case you were interested, or in case you want to try using formulas in MATLAB, this is how you would set it up. And I would say this is probably the most consistent way. And to me, actually the least annoying way to actually do these rate of return problems, because what you'll see later on is when we're using the compound interest tables, we have to do a lot of interpolation. And interpolation is not hard. It's just to me it's just really annoying because it's a lot of guessing and checking and a lot of arithmetic, and it's potential for a lot of mistakes. But for MATLAB, you just write the equation once and then you just find the result, and it's always going to be reliable. Okay. But again, it's up to you, and so I'm not going to force you to do one way or the other, but it's just whichever way you feel most comfortable doing. Okay. All right. Any questions on this? Okay. All right. And so now let's talk kind of about kind of unpack a little bit of what we did in this example, or basically let's talk about the actual procedure of computing rate of return. All right. And so, in the previous example, what we did was we took all of the cash flows in the problem, we computed the present sum, and then we set it equal to 0. Okay. Okay. And so that's one way you can solve for these rate of return problems, right? And so computing net present worth is going to be reliable. Okay? But there's actually multiple ways that you can do it. And actually all of these methods are kind of spin-offs on the same thing. But sometimes one form is more convenient than the other one. Okay. Okay. And so the other methods that you can do is we can say that we can compute the present worth of all the benefits and then we can subtract the present worth of all the costs. And we set that equal to 0. And so essentially that's the exact same thing as computing net present worth and setting it equal to 0. But if you want to think of it in terms of, to group all the benefits together and group all the costs together, find their present worths, and then, plug into this equation. That's another way that you can go about it. Okay. All right. Another way that you can do is you can take a ratio. So we take the present worth of the benefits. Right. And we take the ratio of that with the present worth of the costs. Okay. And we set this equal to 1. Okay, so that's another way that we can do it, which again is just a spin-off of the above equation. It's just put into a different form. Okay. Right, another spin-off of the first equation is just going to be net present worth equal to 0. And so that's what we did for the for the last example. Okay. Another way you can set up the problem, which is, another spin-off of the first one, is you can just move, move the present worth of the cost to the other side of the equation. And so you can do present worth of the benefits is equal to present worth of the costs. Okay. Right. And so yet another spin-off of the same thing. Okay. Or if you're so inclined and it's more convenient to convert everything to a uniform series or to do annual cash flow, you can do it like that too, right? And so you can do EUAW, okay, which remember stands for equivalent uniform annual worth. Okay, this is equal to EUAB minus EUAC. Okay. And we just set that equal to 0. Okay. Right. And so all of these will work. And so mostly just because they're all spin-offs of the exact same formula, but whichever form that you choose to basically make your rate of return formula that you can use to solve for I, all of these things are good. Okay. Any questions on this before we jump into another example? Okay, so let's do one more example, and I think that's probably all that we'll have time for today. Okay. All right, and so in this example, let's say that we have a cash flow diagram that looks like this. Okay, goes up to 9, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so let's say that we have the cash flow looks like this, right? And so on year 0, year 1, year 2, year 3, let's say that all of these are $9,000. Okay. And starting on year 5, we have a uniform series decrease. And these are all going to be 8,360. Okay. All right. And so let's compute the rate of return of this cash flow diagram. Okay. All right. And so, we have so many options available to us. And so, we can set up this equation in any way that we want. But the way that I usually like to do this is I just compute the net present worth. And so there's a little bit more nuance to this cash flow diagram than usual, right? And it's kind of the reason I picked this example, because if you notice, in green right there, we have a uniform series, right? So we have a uniform series of 9,000, but it starts at kind of a strange place, right? Because normally a uniform series start at year 1, but here we have a uniform series that starts on year 0, okay? And so we have to account for that. And so that $9,000 at year 0, we can the way that we can consider that is we can consider that as a separate cash flow that occurs on the present day. Okay, and so this one right here, consider as okay, and so we're going to set that up as a separate cash flow because normally, remember, normally uniform series starts on year 1, but in this case it starts on year 0. Okay, and so that $9,000 we're going to consider separately as a P. Okay, and so if we're computing the net present worth, then that P right there, or that 9,000 on year 0, we're just going to add that as 9,000. Okay. Right, and so this 9,000 is going to be separate from the other 9,000. Okay. Okay. And so this other 9,000 that we're going to put in, this is the actual uniform series that takes place from years 1 through 3. Okay. Right, and so to convert this, we're going to do P over A. We don't know the interest rate, so we're going to say that's I. Okay, and then N is going to be equal to 3 in this case. Okay. So does that make sense? Why I broke those two up? Any questions on that? Okay. Yeah, you have to be careful with these cases, and so normally I think the intuition for a lot of people is that we see kind of 4 arrows in a row, and so the temptation is to say this is just one uniform series that occurs for 4 years, but because it starts at year 0, you have to make this small adjustment here. All right, and so now we have our uniform series loss at the from years 5 to 9, okay. And so we have a minus 8,316. Okay, and since this is a non-standard cash flow, and so since this is a uniform series that occurs later on in the period, right? And so we're going to need to perform 2 conversions here, right? So first thing we're going to do is a P over A conversion. Okay, so P over A I. And we count the amount of years that this uniform series takes place, and so that takes place for 5 years. Right. And then once we perform this P over A conversion, that's going to create a single cash flow on year 4, right? And so we need to take that cash flow in year 4 and then transport that or convert it back to year 0. Okay, and so this is going to be a P over F factor with an unknown interest rate, and the N is 4. Okay. All right. And so here we have a little bit more of a more complicated situation on our hands, right? And so just like our first example, we want to find the interest rate here. But here, it's going to be a little bit harder to use the tables because we can't just outright solve for all the conversion factors, right? And so we have 3 conversion factors here. So 1, 2, 3. Okay. Right. And so, the way that we're going to approach this problem is we're going to start plugging in conversion factors for all of these for the same interest rate, and we're going to see, which one gets closest to 0, or which one, gets us, closest to satisfying this equation, right? Right. And so we're going to start plugging in conversion factors. Okay. For certain interest rates. and we're going to see which gets us closest to 0. Right. Just to kind of give you a spoiler for for how this problem's going to go, because I don't know if we're going to finish it within the last 5 minutes, is that we're not going to find an interest rate that gets us close to 0, but we are going to be able to find one. We're going to find 2 interest rates where we know it's going to exist between. Okay, because what we're looking for here is we're going to look for the place where the present worth actually starts to change sign. Okay, and so when if in this case it's going to go from negative to positive, or if the present worths go from positive to negative, we know that the true rate of return is going to exist somewhere in between those two options. Okay. All right. Any questions on this before we start plugging stuff in? Okay. All right. And so let's go ahead and start plugging things in. Okay. All right. And so in this case, this is it's kind of, you can almost think of it as like a true blind test, because we don't know what the interest rate is. And so we're just going to have to start from the bottom and then kind of work our way up to wherever the rate of return is, right? And so let's start with an interest rate of 1. Okay. Right. And so let's go to the compound interest tables for I is equal to 1%, and then start filling in those conversion factors, right? Right. And so the present worth for when I is equal to 1, okay, this is equal to 9,000 plus the P over A factor for I is equal to 1% and 3. Okay, and so this is going to be 9,000 times 2.941. Okay, and so this is the P over A factor for N is equal to 3. Okay, for I is equal to 1%. Okay, and then from this we're going to subtract our 8316. Okay. And we're going to plug in our 2 other conversion factors. Okay, and so this is going to be 4.853. Okay, and this right here is our P over A factor for N is equal to 5 with I is equal to 1%. Okay, and then we have a 0.961. Okay, and this right here is our P over F factor with N is equal to 4, right, from the previous page. And what we get is minus 3,314 and 60 cents. Okay. Right. And so not quite 0 yet, right? And so we still have a ways to go. Right? And so now let's try I is equal to 2%. Right? And we're almost out of time, and so I'm going to zoom through this a little bit. Okay. And so if we switch the compound interest tables now to 2% and we plug in the exact same, we look up the same conversion factors. Okay. So we have 9,000 plus 9,000. Okay. And so we shift up to 2%, and then that P over A factor is going to be 2.884. Okay. It's going to be 4.713. This is going to be 0.9238. Okay. We plug that in, we get a minus 1,250 and 78 cents. Okay. All right. All right, so we're getting warmer, but not quite yet. And so let's finally try I is equal to 3. Okay. All right, so I is equal to 3. We're going to plug in everything as before. And so we have a 9,000 plus 9,000. Times 2.829 minus 8316 times 4.580 times 0.8885. Okay, so plug all those things in and we'll get 620 and 45 cents. Okay. All right. Oh yeah, I is equal to 1% on the first one. Yeah. All right. And so you can see from here that we don't really get anything closer to 0. And if we try interest rates that are higher than this, we're going to get farther and farther away. Okay. But what we should notice is that in between these two, right, our present worth goes from negative to positive. And so somewhere in between 2 and 3%, we have a present worth of 0. And so this tells us that our rate of return is somewhere in between 2 and 3. Okay. And the way we're going to find this, which is what we're going to do on Thursday, is we're going to do this by interpolation between these two values. Okay. All right. Any final questions on this before we wrap up for today?
Wait, Professor,
Yep.
can you explain one more time how you know it's between 2 and 3%?
Yeah. And so we know it's between 2 and 3% because when we did I is equal to 2, we had a negative number, right? And then when we did I is equal to 3%, we got a positive number, right? And so in between 2 and 3%, it had to cross the x-axis. And because the rate of return is one kind of continuous line. And so if it goes from negative to positive, then it has to cross 0 somewhere in between there.
Oh, okay. I didn't see the negative sign.
Yeah. All right. And so I apologize, I went a little bit over time, and so I apologize for that. And so thank you guys for tuning in today. I'm going to put out the study guide. I have a little bit something to do right after class, and then I'll put out the study guide after that. And so keep an eye out for that. And so have a good rest of your afternoon, guys, and I'll see you on Thursday.
All right. Thank you, Professor.
Thanks, guys.
Professor.
Yep.
Can I ask one question?
Sure.
Can you define principal paid one more time?
Sure. And so when you're paying off a loan, the amount that you owe on the loan, that's called your principal, right? And so the $2,400 that we started out with here in this loan,
right,
that's the total principal that you have to pay, right?
Oh, okay.
And so the principal paid is how much of your payment on that period is actually going towards paying off your balance. And so each period you're paying the exact same amount every time, right?
Right.
So each period on the loan, you're paying $603.84. That's consistent. And so that's not going to change.
Right.
And so out of that $603.84, some of that has to be taken away to pay for the interest, right?
Oh, okay.
And so in this case, our interest rate was super low. So our interest rate for this problem was, 0.25%.
Right.
And so the way that we compute the interest is that we take 0.25% of our balance for that period, right? And so since our balance in the first period was $2,400, we
right,
take 0.25% of that, that's $6, right? And
right,
so out of the $603 that we're paying that in that period, we subtract $6 from that because that goes to pay the interest.
Oh,
and
okay.
Whatever's left, that's the principal paid. And so this is the amount that we're using towards chipping away from our balance.
Right. Oh, okay. Yeah, that makes sense. Thank you so much.
Yep. Nick, did you have any more questions before we wrap up for today? Okay. All right. Have a good day. I'll see you Thursday.